This here shows the results of a recent security run where an AI system found 16 zero-day vulnerabilities hidden deep inside core Windows components. Four of those were critical remote code execution flaws. In simple terms, those are serious bugs that could allow an attacker to run malicious code from across a network. Looking at this here from Microsoft, the header reads, Defense at AI Speed. The first bullet point makes a big statement. AI vulnerability discovery has officially moved from being a research experiment into production grade enterprise defense. On the left, traditional security scanners work more like metal detectors. They scan individual files for suspicious patterns, signatures, or known warning signs. But the MDASH agentic harness works more like a specialized security team. It uses deeper reasoning to trace how code behaves across multiple files at once. Finding flaws in modern software takes real investigation. Spotting one suspicious line of code is not enough to prove something is actually dangerous. This shows how multi-file investigation works. Notice the center, the M-dash orchestrator. Instead of relying on one massive AI model to do everything, the orchestrator routes tasks to a network of more than 100 specialized AI agents. Each agent is assigned a specific job. This is where traditional scanners struggle. On the left, the scanner checks one file, like a car file, and passes it because that file looks safe on its own. But on the right, M-dash maps the connections across 6 different files and finds a deterministic double-free memory error. That is a serious vulnerability that only becomes visible when you understand how the files interact with each other. The real breakthrough in AI security is not just having a smarter model, it is building a system that can divide the work, investigate across thousands of connected files, and reason through the full code base. This map shows the autonomous sequence. It starts at Node 1, Prepare. This is where the system takes in the code base and builds a threat model. Then it moves along the glowing path to Node 2, Scan. This is where specialized auditor agents begin searching for possible flaws. Next, the process reaches the central validate hub. This is where the system tries to eliminate false positives. Different AI personas take on the role of debaters, arguing for and against a finding to determine whether the bug is actually reachable. Finally, the workflow reaches the prove node. Instead of stopping at a theoretical warning, the system tries to build a dynamic proof of concept on its own. In other words, it generates an actual input that triggers the code and proves the bug is real. That validation process is what separates a useful security tool from a system that just creates a lot of noisy alerts. It gives engineers proven, actionable issues they can actually fix. This architectural map of the Windows network stack shows exactly where the pipeline proved its value. The red markers show the 16 vulnerabilities M-dash discovered. These bugs span both user mode and the highly sensitive kernel mode, affecting components that handle core networking and authentication. These three gauges show Microsoft's internal ground truth testing. On the left, the system achieved a 100% success rate, finding 21 deliberately planted vulnerabilities. The middle and right gauges show that it recalled 96% and 100% of historical bugs in major network components. Looking externally, this leaderboard shows the CyberGem public benchmark, which tests an agent's ability to reproduce real-world vulnerabilities on its own. M-dash currently leads the board. The top row shows an 88.4% success rate, beating competing single-model systems. This stack shows the long-term strategy for enterprise defense. The top layer is the language model. That layer will keep changing as different models leapfrog each other and get replaced over time. But the deeper layers underneath it, the validation agents, domain plugins, and threat models, are the more lasting investment. For organizations evaluating AI security, the lesson is clear. Do not focus only on which model is being used today. Focus on the orchestration system built around the model. This split-screen graphic highlights the bigger consequence of this technology. On the left, we have defender agents, but on the right, we see the threat. If defenders can use multi-agent systems to automatically find and prove bugs, attackers can eventually use similar workflows to exploit them. We are entering a faster, highly automated race where vulnerability discovery can run continuously in the background, with very little human input. Returning to Microsoft's presentation, the final bullet point summarizes the reality of this shift. Finding, validating, and containing critical flaws can now happen at a speed humans simply cannot match. Software auditing is no longer limited by human working hours. Looking at the bottom panel of the split screen, the message for enterprise defense becomes clear. Organizations need to run these agentic systems against their own code before attackers can use similar techniques against them. MDASH is a powerful piece of defensive engineering, but more importantly, it acts like the starting gun for an automated cyber arms race, where orchestration, validation, and raw computational speed become the biggest advantages.